We are discussing graphing relations. What is graphing relation? That is, we need to put the graph on the, or you can say the graph, we need to put the relationship. What is relation and how do we show it in the graph? Whenever your teacher asks you that you need to show your work, what do you show? You need to write a complete solution. That is, if the question is being asked that a cone has height 8 meter and base radius 10 meter, and you have to determine the volume, then what you will do? First of all, you'll say that radius is 10 meter, the height is 8, the formula for the volume is 1 by 3 pi r square into h. You substitute this r and h and you find the formula. Using the formula, the answer and the volume of the cone is approximately this much, 838 you write. So this is how you write. Now when we solve this using the left hand side, that is this one, this is quite detailed. But suppose you are not aware of the question. Could you follow the thinking of the student on the right? If the student has just did this, is this correct? So in order to write a solution, you need to first of all write the solution, show all the steps, and this should include graph, tables and diagrams. This is where the graphs comes into picture. Then all the symbols that you use, you need to include the symbols like and the variables, and if you are able to write the sentence, it will be very good. And also include part of the question in the answer. So how do we interpret these scatter plots, and what are these scatter plots? Scatter plots are simply when you have some points lying here in some plane, that is, these are scattered points, and when we plot these points using the Cartesian coordinate system, we say them as scatter plot. There is a team, the New York Liberty, NBA, WNBA to be more precise. Now the statistics of the player, such as what the point have been scored, these are being recorded. And these data can be used to decide who should play, who is scoring more goals or who is consistent player. So if you want to interpret a scatter plot like this, just consider that during some season, say 2005 regular season, 15 athletes played for the New York Liberty. Now this scatter plot shows data for the team. Now one athlete played for 361 minutes. See, from here to here, one athlete played for 360 minutes. And what point did she score? 361, that is around, if you take this as say 100, 200, 300, 400. So around 300 and in between 361 like this. So how many points does she score? The point is around 100. Around 100. And another athlete scored 353 points. Say here, 353 points. How many minutes did she play? So you just have to follow this line and you see this is the point, or this is the data or the XY coordinate of that point. So just go down. It is around 800, say 900, 1000, 1000 means 1000. So this is around 1000, say 20 or 30 like this. So this is how the relationship between the time played and the number of points being scored can be shown using a scatter plot. So what is a scatter plot? Let us again try to investigate it. That a scatter plot is used to relate two different measures. What we observed in the previous discussion was each player scored what number of scoring she has and the time she played. So the relationship between the measures is now shown by a trend in these points. What is the trend? Whether the trend is like this, whether the trend is like this, or whether the trend is like this. So it shows it all. And here is a mark. If you see this, the mark, this mark like this kind of mark, this indicates that certain numbers are missing from this scale. So we don't consider these numbers. Okay, we just start from 0 and then go to 80. Again, here we are also missing some numbers. So the relationship between the measure is, as I said, is shown by the trend. Here we have the height of the student and the age of the student. So the points in this scatter plot shows a relationship. That is, if you move on the x-axis, that is the age is increased, the height also increases, and this is natural. If you see a kid, he may be smaller. If you see him sometime or some years after, he'll be taller. And here if you see this is the time and the height. So height and time to travel to school for high school students. So the point in this scatter plot, they have no relationship. They are just scattered. So there is no relationship. We can't make like this. We can't make like this. There is no trend. All these are scattered. But here you find a proper scatter. If I make it inside some figure, you see there is a proper trend showing. So we have an owner of an ice cream stand wants to predict the number of ice cream cones she will sell each day. And with her experience, she thinks that the number may be related to the daily maximum temperature. So for 2 weeks, the owner records the maximum temperature and the number of cones she sold each day. She then draws a scatter plot. If you see this is the maximum temperature and this is the cone she sold. And the scatter plot shows a trend in this data. The points go up to the right. That is, as the daily maximum temperature increases, more cones are sold. That is, if it is around say 26 degree, this much of cone is being sold, say 120 to 140. So it may be here 130. So we can say 135 are sold. But if the temperature rose to 32 degree, and even after that, say 33 degree, this much, see, this is 215 around, 215 cones are being sold. So this scatter plot shows a trend in the data. As the point goes up to the right, that is the daily maximum temperature increases, the cones are also being sold in an increased amount. So in order to predict the number of cones that might be sold, that is, we need to draw a line of best fit. That means it may not contain all the points, but it must contain maximum points. For that, we need a ruler on the graph so that it follows the path of the points. Draw a straight line, we need to draw a straight line along the edge of the ruler. That is like this. Okay. This is the way of just trying to follow the trend. Maximum points, we just try to cover maximum points onto the ruler or onto the line or near to the line. Say one day it is predicted the maximum temperature is 31. In order to estimate the number of cones being sold, we can use the best fit line like this. So we can start from here 31 and you can go like this. So it is around 186 cones might be sold. This is the estimation through the scatter plot. Then there is one more thing. A weather forecaster measures and plots the temperature every 2 hours on a summer day. Now the temperature decreases from midnight to 4 a.m. This always happens. In the night the temperature decreases and it increases as the sun rises. It reaches the maximum in the afternoon time. Then again it decreases during the late afternoon, that is the evening time. Late afternoon and evening time. And the point do not lie on a straight line, but they are related. That is, you will not get a straight line, but you will get a curve. And we call this curve of best fit. So in order to draw a curve of best fit, we just need to take these points and draw a smooth hand curve, as many as possible points we can contain in this line. So if you see this, the greatest temperature occurred, if this is the time of day, say 12 midnight, 6 a.m., 12 noon and 6 p.m. These are the temperatures. So if you see that the maximum temperature is here. So this is between around 2 and 3 p.m. And we can easily use or employ this curve to estimate the temperature at 5 a.m. So if this is 6 a.m., Here this is 6 a.m. Here it will be 5 a.m. So just take the point or draw a line parallel to y-axis, and now draw from this point, draw a line parallel to x-axis, and where it intersects, this is the number. So this is around 15 degree. So we move up to the curve, then across the temperature axis. So at 5 a.m. the temperature would be around 15 degrees centigrade. Now we can go ahead, we can explore how the volume of pyramid is related to its height. We know that the volume of the pyramid is 1 by 3 base into height. So we need to calculate the volume. So we have several square pyramids being shown here with the base area, all have the base area as 9 centimeters. So let me tell you again that the volume of the pyramid is 1 by 3, the base area into height. So if you see here, base area is 9, all the pyramids have base area as 9, and the height is here 1, here is 2, so likewise till here 5. So we see there are certain numbers. Now let us draw, or let us show it in the graph. We have the height increasing, and we see the volume is also increasing. So height increased by 1, the volume increased by 3. See 3, 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3, 14 minus 12 is 3. So as the height increased by 1 unit, that is 1 centimeter, the volume increases by 3 centimeter. We can just draw the line like this, and with height, between the heights of the table we can find out. That is, if the height is 1, we know that volume is this. If the height is 2, we know the volume is 6. But what about 1.5? If the height is 1.5, what will be the volume, or any other value? We can always find out using this. See, this is 1.5, go up here and go make a line parallel to the x-axis. This will be the value around, see, 4 to 8. So this will be 6, this will be around 5 or something, right? Just giving an example. So since the graph is a straight line, this is a linear relationship between the volume of the pyramid and the height of the pyramid. And we can use this graph to estimate, as I said. Now let us take a proper example, that when the base area is 9 and now the height is 2.5, that is, we want to find out between this and this, 6 and 9. So it has to come, the area must come between 6 and 9, and you'll see that it is going to follow this trend. That means we are at 2.5, draw a line which is parallel to the volume axis, and now at this, when it intersects this straight line, that is what we have drawn, linear relation, and draw a line which is parallel to the height axis, and when it intersects here, this is around 7.5. See, the 7.5 is between 6 and 9, and this is showing the volume of the pyramid when the height is 2.5, which is not shown in this table or our doings here, but we can find it out always. And if you see that these pyramids, the volume is 3 times the height. Now we can always find the volume. It is all easy to calculate the volume using this rule. The height is 2.5. What is the volume? 3 into 2.5. Say if the height is 3.5, what will be the volume? Just multiply it by 3. You'll get the value. So the volume of pyramid, if you see, the base area is 9 centimeters square, height is 2.5, is simply 7.5. This is computed by the rule or the law we saw, and also by the trend in the graph. So we'll apply this to one of the question. Now if we consider this question, or you can say example, then how are these angles in an isosceles triangle? They are related. So we'll just make a table. If you are aware of isosceles triangle, this triangle has 2 sides equal. That means these 2 angles are also equal. So when the sum measure of these 2 angles, say one angle is 10 degree and this is also 10 degree, what will be this angle? This will be 180 minus 10 minus 10, that is 180 minus 20, that is 160. So what do you get here? 160 degree. Again, so this is the table we can make for 10 degree. The third angle measure is 160 degree. Let us take some other angle. If this is 60, this is 60. So 60 is 120. Just subtract 120 from 180, you get 60. So this is the table. But what you see here in this table is there is a proper trend, that is, for increase of 10 degree in the equal angle, there is a decrease of 20 degree in the third angle, which is the unequal angle. So we can make a graph of equal measure angle and the third angle measure, and we can make a line like this, or we can just join these points. If you see, we have just plotted these points 10, 160. So x is 10, so it is 160. See, x is 10, this is going to be 160. So this is 10, 160. And the last one is 80, 20. So this is 80. So this is 20. So this is the line linear relationship. But one thing is there, because of this linear relationship, we can easily find out any value between this. So if you see, consider 25. So if the equal measure is 25, what will be the value of third angle? Just see, 25. So if it is 25, say this is 10, 20, 30, 40, 50. So 10, 20, this is 25. So just mark it here. I'll just try to devise it. So this is 10, 20 and 25. So if I just join this by making a parallel line, and now I can come here. So this is around 130. So exactly this 35 value, this 25 value will have the third angle measure as 130, and which is exact. So this is how we employ the plotting or plot to find out any intermediate value. Now we have this plankton. So plankton and seaweed, which are the basis of ocean food chain, they need sunlight in order to survive. So as the sunlight enters this ocean, if you see here, it is absorbed and scattered by the water. And this table and a graph, this shows how the amount of sunlight that penetrates clear tropical ocean like this, water, changes with depth. So if the depth is 0, the light is 100% penetrated. But if the depth is 150, the light penetration is only 1%. So this is the graph which we can make. This is the depth and this is the light penetration. So for 0, see, for 0 we have 100, and for 150 we have 1. So for 150 we have just 1. And this is not a linear relationship. This is a curvilinear, you can say, curve relationship. So it's a smooth curve. So here at a depth of say 40 meter, because it is not given what is the depth, what is the value of light penetration at 40 meter. So if you see 40 meter, this is the 40 meter, so it will be 30% of light will penetrate. So at a depth of 100, it will be around 5%. So this is how we can also find out the value of some intermediate points here using this is a relationship which is a curve, and this relationship is a non-linear one. We have one more example here. So a typical North American adult consumes about 200 mg of caffeine a day. So this is 200 mg caffeine a day. Caffeine has a half-life of about 6 hours. That is, after 6 hours of consumption, half the caffeine remains in person's body. Caffeine occurs naturally in coffee, beans, cocoa beans, cola nuts, tea leaves. It is also found in products such as coffee, tea, some energy drinks and soft drinks. So this is what people use or employ just to energize themselves. So we need to copy and complete this table, how much is left and what trends are being shown, and we have to grab the data also, and about how much caffeine will remain after 9 hours, after 36 hours. As we see that after 6 hours, half will remain. So this we can make easily. See, it is 0. When the time is 0, it is 200. But when the time is 6 hours, it becomes half. So it will be 100. Then again 12 hours, so it will again be halved. So 100 by 2, that is 50. Then after 18 hours, it will be again half, 25. Then after 24, it will be again half, 25 by 2, that is 12.5. Now we can make a graph. So we have a time here, we have a mass of caffeine in milligram. So this is how we can draw. For time 0 it is 200, for time 0 it is 200, for time 6 if we make like 10, so we can just draw it here. For 6 it will be around 100, so for 6 we have 100. For say 18 it will be 25, say some 18 is here, so we will get some 25 here, and then we will have 24, so 24 will have around 12.5 here. So we can make a graph like this, a curve graph. So if you these are the things. The trend, as you see here, is a curve which we draw as a best fit curve, and the trend is that the mass of caffeine is decreasing as the time is increasing. So it's the graph will be a curve. The graph is a curve, it goes down to the right, and from the graph the mass of caffeine remaining after 9 hours is what? See, in between this 9 hour, it has to be between this, so it is 70 mg. So 9 hours, that is the time is 9 hours, it will be around 70 mg. So this is around 70 mg. And but if you extend the graph, the mass of caffeine after 36 hours, that is if you go here, somewhere here, so it will be around 5 mg roundabout. And we can also measure, or we can also determine this time by extending the table. So 30 hours 6.25, 36 it's 3.125, and we can go on and on and on, and we can find out the time after which it will be 0. So this graph is somewhat different. It shows the height of the water in a bathtub over a time, and the key points are probably these points. Okay, this is just an idea, so we can just label them like this. So height of the water is this, and time is here this. So the possible, if we think about the possible reasons for these abrupt changes of the points, at point A, see, at point A, the bathtub is empty. Let me show you here. At this point A, bath is empty. A person puts in the plug and turns on the water now. From A to B, the water is filling up in the tub. From A to B. At point B, the person gets into the tub now, and because of his body or his body mass, the volume of the water will again increase. So there is a shift increase, or water level will increase suddenly. Now the person sits in the tub from point D to E, so the water remains the same. It is not, we are just assuming that water is not spilling out. After this, from D to E, he is just sitting. After E, he pulls out the plug and the water begins to drain now. So it is coming down, and he gets out of the tub, causing the water level to go down again. And from G to H, the water continues to go out or to drain from the tub. And after this point H, the drain is this water has been drained and it is empty. So make a question, or we'll try to solve a question regarding this. So this is a graph that shows the George distance from home as he walks to the school. So we have to describe his walk. So see, I'll show you here. This is the time and this is the distance. So at point A, he is at home. So it is the distance and time is 0. Now he goes up to the right like this. George is walking for 3 minutes. He walks now 300 meters like this. So 3 minutes and 300 meters here. Now George is walking 3 minutes, so he walks 300 meters from B to C here, from this point to this point. George is still walking away from the home. The segment BC is less steep than that from A to B. So George's average speed has decreased now, and he is walking slower. As you see, this is the angle, and now this is the angle. So if you draw a line, the angles have changed. So now he is walking slower, and he is walking slower. He is walking for 4 minutes and travels 200 meters. From 300 to 500 he goes, and the time is from here to here. That is around 4 minutes he travels for 200 meters. Now from C to D, the segment is horizontal. That is, this means the time is passing. That is, the George is not moving anywhere. He is just standing here. There is no movement from this time to this time. That is 2 minutes he is standing. From D to E, George continues his walk to school at the same average speed from B to C, from this point to this point, that is B to C. Same angle is there. This angle and this angle are same. He walks for 4 minutes and he again travels from this point to this point. If you see, this is 200 meters. So it takes 13 meters from this point to this point. It takes 13 meters from here to here, and from here to here this is 700 meters, and from the time is 13 meters. So he walks 700 meters for 13 minutes in order to reach the school. So what do we found? What do we learn here? That there are certain line of best fit, and this is the curve best fit, this is the linear best fit, and then we have a linear relation. This is a graph which has a straight line. This is just an example of a perimeter of a rectangle with 3. And then we have a relation that does not have a straight line. This is a non-linear relationship. For example, a half-life of caffeine in the body we just saw in the discussion previously. So this was about this topic, that is graphing relationship. Thank you so much. Take care of yourself.